Not every truth wants to be revealed. Are you ready to open the file? The universe we can see may be only a very small part of the truth. The shimmering stars in the sky, the vast spiral galaxies, the glowing clouds of gas in deep space, everything humanity can observe, accounts for less than 5% of the entire universe. The rest is something invisible. Scientists call it dark matter. Dark matter does not emit light. It does not reflect light. It does not absorb light. It cannot be seen through a telescope, cannot be photographed, and cannot be touched. Yet, dark matter shapes entire galaxies. Without it, galaxies would spin too fast and tear apart. Stars would be unable to maintain stable orbits, and the universe as we know it might not even exist. The concept of dark matter emerged in the 1930s, when astronomers realized that galaxies were rotating much faster than the amount of observable matter could account for. In other words, there was something holding the galaxies together, an invisible gravitational force. For decades, the dark matter hypothesis gradually became a cornerstone of modern cosmology. But there is a major problem. No one has ever detected dark matter directly. Entering 2026, the hunt for dark matter has entered a new phase. Deep underground, kilometers below the surface, extremely sensitive detectors are placed in completely sealed laboratories, isolated from cosmic radiation and interference from the Earth's environment. They are designed to wait for a tiny collision between a hypothetical dark matter particle and a regular atom, a signal so faint that it may occur only a few times over many years. In space, orbiting observatories and next-generation telescopes are searching for indirect traces, unusual gamma rays, distortions of light caused by gravitational lensing, unexplained motions of distant galaxy clusters. Every piece of data collected is analyzed by artificial intelligence systems, in the hope of uncovering a pattern that humans might have missed. Yet, the more they search, the more puzzled scientists become. The previously predicted particles, such as WIMPs, axions, or exotic neutrinos, have still not appeared, and from this, an increasingly pressing question arises: could dark matter truly be matter at all? Some physicists suggest that we might be looking for the wrong thing. Instead of a new type of particle, dark matter could be a manifestation of gravitational laws that are not yet fully understood. Perhaps gravity does not operate the way we think on a cosmic scale, or perhaps there are extra spatial dimensions, fundamental structures of the universe, that current science cannot observe directly. It is worth noting, none of these hypotheses are considered final conclusions. In science, doubt is not failure, it is the motivation to move forward. Dark matter is not a story about aliens or secret forces. It is a true scientific mystery, lying at the boundary between what we know and what remains beyond our understanding. Perhaps in the future, a tiny signal will appear in an underground detector. An unusual piece of data will be recognized by AI, or an entirely new theory will change the way we perceive the universe. Until then, dark matter remains, invisible, silent, yet governing everything. It reminds us that the universe is not only made of what we can see, but also of things we are not yet capable of understanding. And perhaps, the greatest mystery of the universe is not what hides in the dark, but the limits of human perception itself. The truth is still hidden.